Okay, class, so I'd like to review the neuroregulation of blood pressure homeostasis with you. There will be questions on the exam over this, and I sent out an announcement saying that this is really what you want to understand to be able to work through the extra credit activity on the exam. So I would have done this on my screen with my stylus, but Mr. Bear ate my stylus a couple days ago, so I'm having to make this video for you. But anyway, so here we go. Neuroregulation. So remember, when we have fluctuations in blood pressure, there's autoregulatory things that will go on. There's a lot of endocrine stuff that will go on, right? We've been talking about the endocrine pathways in renal physiology. So we'll talk more about that in our next unit. But what we're focusing on here is neuroregulation. So we're going to begin with receptors called baroreceptors right here. And the baroreceptors are receptors found in the aortic arch and in the carotid sinus up here in the neck and the carotid artery. They detect changes in blood pressure, and they will send that information, that stimuli, to the brain, specifically to the medulla oblongata, where the cardiac center and vasomotor center are housed. The cardiac center and vasomotor center will then respond in a way to bring blood pressure back to its normal range. So let me review those two centers with you again here. So the cardiac center, there are actually two components to the cardiac center. You have the cardioacceleratory center, which will utilize sympathetic nerve fibers, releasing norepinephrine, which will lead to an increase in heart rate. You have the cardioinhibitory center, which will utilize parasympathetic pathways, releasing acetylcholine, which will lower heart rate. Okay, so the cardiac center is going to alter the rate at which the heart beats. But then we have the vasomotor center. And the vasomotor center is responsible for causing either vasoconstriction or vasodilation at the blood vessels. So if you have an increase in vasomotor center activity, that causes the smooth muscle in the wall of the blood vessel to contract, leading to vasoconstriction, again at the blood vessels. So if those blood vessels constrict, that's going to increase resistance and increase blood pressure. If you have a decrease in vasomotor activity, that's going to cause the smooth muscle in the wall of the blood vessels to relax, leading to vasodilation, which is going to decrease resistance and decrease blood pressure. Okay, so that's our background information. Then we put all this to work, put it together, and I'm going to use that document that I gave you in class when we did this. I like this picture awfully well. So we're going to look at, again, this is neuroregulation. Let's start here. We're homeostasis, we're in homeostasis. Blood pressure is within normal ranges. When we have an increase in blood pressure, that's detected by the baroreceptors. That information, that stimuli, is taken to the brains, again, specifically the medulla oblongata, to both the cardiac center and the vasomotor center. If blood pressure is too high, the cardiac center, what we're going to see happening is sympathetic impulses are going to decline to decrease heart rate. So we're going to see a decline in sympathetic activity, so decrease in the cardioacceleratory portion of the cardiac center, but we'll see an increase in the cardioinhibitory, although that's not indicated in our drawing. So what we're going to find then, again, is that we're going to be releasing acetylcholine, not releasing norepinephrine, and that should lead to a decrease in heart rate. That will decrease cardiac output. In terms of what's going to happen at the vasomotor center in response to increased blood pressure, we're going to see the rate of the vasomotor impulses decline. So we're going to see a decrease in the activity of the vasomotor center, which again is going to allow for vasodilation to occur. These smooth muscles relax, opening up that blood vessel, increasing the diameter of the blood vessel, which will decrease resistance. So when we have a decrease in cardiac output and a decrease in resistance, that's going to bring our blood pressure back down to normal ranges. Okay, now if we're looking at a decrease in blood pressure, so when blood pressure decreases, Again, that change in blood pressure is detected by baroreceptors. They will send that stimuli, that information, to the medulla oblongata, again, specifically to the cardiac center and vasomotor center. Our blood pressure is too low, so we want to speed up heart rate. So we're going to, or rather, the cardioacceleratory center will go to work. So we're going to have sympathetic nerve fibers releasing norepinephrine, increasing heart rate. We're going to see a decrease in the activity of the cardioinhibitory center. The vasomotor center, we want to stimulate that system, so we're going to see an increase in the activity of the vasomotor fibers, stimulating vasoconstriction. The smooth muscles contract, decreasing the size of the lumen, increasing blood pressure, increasing resistance. So when we have an increase in cardiac output and an increase in resistance, our blood pressure returns to normal ranges. Okay, so there you have it. There's a review or overview of the document that we looked at in class on Monday. Thank you.